As with our sum and difference of angle formulas, as we looked at in the last section, there are other uses for this particular expression right here. Here's a couple. We can rewrite some expressions if they look a little bit weird that involve trigonometric functions, as long as we recognize the formulas that they go with. So for example, in our first problem, we're told to write the cosine squared 5x, the square of the cosine of 5x, minus the square of the sine of 5x as a single function. Now, we haven't dealt with any functions that deal with 5x, but we sure have dealt with functions as an identity that deals with the difference of a sine and a cosine. There's squares right here, cosine squared alpha minus sine squared alpha. And our formula, cosine squared alpha minus sine squared alpha, is the same as saying the cosine of 2 times the angle alpha. Well, what's replacing alpha in this case? It looks like alpha is being replaced by the quantity 5x. So if we take that to be what's happening right here, then in fact we're saying that we're going to have the cosine of 2 times 5x. Now again, remember, it's not cosine times 2 times 5. It's cosine of the quantity or the angle 2 times 5x. But if we simplify that down a little bit more, that's the same thing as saying the cosine of 10x. So in fact, we've just used our double angle formula as a way of simplifying or rewriting a much more complicated looking trigonometric expression into one that's a little bit easier to manage right here. Another reason to be happy. Well, let's talk about this one. What about the tangent of 3 theta over 1 minus tangent squared theta? Well, which formula does that look like? But, well, clearly this one, right? Our formula is 2. Let me write this out in a different color here. Our formula is actually 2 tangent of some angle alpha divided by 1 minus the square of the tangent of alpha. Now there are a couple of differences between this one and the one that we were dealing with, where this is going to wind up giving us the tangent of 2 times the angle alpha. There's no 2 right here, right? So since there's no 2, we might ask ourselves, what do we do? Well, if it is the case that the 2's not here, but on the other side, we can just simply take 1/2 of this identity, as long as we remember that whatever we got for our tangent of 2 alpha, we take half of that. Now here's the other thing. What's taking the place of alpha? It looks like alpha is replacing 3 theta. So if we take that to be the case, that tangent of alpha divided by 1 minus the square of the tangent of alpha is the same thing as 1/2 times the tangent of 2 alpha. Then replacing alpha with 3 theta means that we're going to get our expression right here of 1/2 times the tangent of 2 times 3 alpha. And kind of as we said 3 theta, and kind of like we said in this expression above it, we can simplify that and get 1/2 times the tangent of 6 theta. And that would be the single expression function that we're looking for. So we're done with this one.